Well, welcome to our lesson on classes of functions. In this lesson, you'll be learning how to identify functions from their graph and also to identify functions just from looking at their equations. So I'm going to buzz through a couple of different, I think there's a total of 9 different common functions here. And most of these you've already seen. The square root function is this function here where we're limiting our domain to the positive square root values. So you're familiar with that one. And the rational function we've talked about, it's where you have something that's represented as a fraction. And the general form for the equation is given here. P and Q are just different polynomial functions. And we've talked about these where they can have asymptotes or they can have holes in the graph. And then the inverse variation function is a specific example of the rational function where you just have the numerator is a constant function, it's just a number. So you might have like 1 over x or 3 over x, something like that. And so that one is a special case of the rational function. And then we also have the constant function. Now the constant function is when you have y equals a number, it's always a horizontal line. You'll never have x equal to a number because that would be a vertical line and that's not a function. The direct variation function, y equals a times x, that's where a is any number and you're going to have just a slanted line. Okay. And then the identity function is a special case of the direct variation function. So the identity function is the one that goes through the origin and the slope is 1. The greatest integer function, this is one that you may have seen before. We haven't spent a lot of time on that this year, but I wanted to throw this in here so you understand and can at least recognize it. The equation is represented by these like double brackets. And you have your variable inside that double bracket, and it's a step function is another name for the greatest integer function because it looks like stair steps, okay? And we'll talk more about that in class. The absolute value function is the next one. It looks like a V where you have positive values and negative values based on what you put in. You'll always get out positive values from your absolute value equation. And then quadratic functions we've talked about extensively. You're pretty familiar with those. The highest exponent on the variable is 2. It can open up or it can open down. So just some examples. Our example says to identify the following functions from their graphs. So first of all, letter A. I think all of you could probably identify this. It's a parabola. So it is a quadratic function. Letter B, this one has the shape of a V, so we know that that one is an absolute value function. So I've included 2 for you to figure out. So letter C might be a little bit tricky, so see what you can come up with for letters C and D. And then in this slide we're going to talk about identifying the functions from their equation. So this one has an absolute value sign in it, so it will look like a letter V. Okay, it's an absolute value function. If we were to graph that, we could pick values for x and then make a table or a chart of xy values. Here's what it looks like. The -1 just translates that down 1 unit. Letter B, down below that, hopefully you recognize that equation as a direct variation function. The slope is -2/3, so it's going to have a negative slope to it, so the graph looks like that, always going through the origin. So I have 2 for you to do over on the right-hand side, letters C and D. So see if you can identify from the equation each of those functions, and go ahead and do a little sketch just by plugging in values for x and calculating the outputs for y. Really short video for you. See you in class.